Hi, I want to start chapter number 3 regarding free fall or falling object and projectile motion. About the free fall, imagine there is an object here and it has an initial height with respect to the ground, which is here at the bottom. This is the ground. This is your object here. From this height, for example, I want to release it. If you release this object, it will fall. Why do you have this situation? Why is it going downward? Because of a field which is around this object. It is called gravity. Gravity is a kind of attraction between your object and the ground. So actually, the Earth planet has gravity, and gravity causes acceleration for this object, and it will make go downward. In other words, it will generate gravity or acceleration for this object, and it will go down. Consequently, this motion called free fall, and that object called falling object. Therefore, here, your object will go downward like this. Downward motion. Why do you have this kind of downward motion? Because of gravity. I mean, every planet has gravity, but the value is different. According to many experiments performed by physicists, gravity value close to Earth planet has been obtained. And this value has a specific number. The gravity in physics is represented by G, which is gravity. And G value, based on many experiments, close to Earth planet, it is 9.81 meter per second square. You know that the acceleration has a unit, and unit of acceleration is meter per second square. I talked about this unit in the first lecture, if you remember, meter per second square. In other words, falling object has acceleration, but this acceleration is always constant value, which is unique. That's G, if you're close to Earth planet. And G value is always 9.81. It doesn't change. But if you are very far from Earth planet, at that moment, gravity is different. Now you have to find this value for that specific location. Therefore, for falling object, there should be an acceleration. And this acceleration equal to gravity. I'm talking about only falling object. As a matter of fact, falling object and free fall have acceleration, and they have rectilinear motion, but that's vertical. If you remember, I talked about the rectilinear motion in the first lecture, but it is horizontal. In this chapter, I would like to talk about the a straight line of the trajectory or rectilinear motion, but that's vertical movement. And you know, falling object is a rectilinear motion along the vertical line. Consequently, here, you have acceleration and you have rectilinear motion. But there is a difference between vertical rectilinear motion and horizontal rectilinear motion. It's related to acceleration. For example, for chapter number 2 or describing motion, we have horizontal movements. And you can have any numbers for acceleration related to your movements. For example, acceleration or A can be 1, can be 10, can be 27, or it can be negative like -5 or -8 or -73, whatever. You can have any number. But over here, for falling object, you have always a unique value, which is 9.81, close to Earth planet. You cannot have anything else. It is impossible to have different number. This is the difference between falling object and regular accelerated motion along the horizontal line. This is only difference between these two. Consequently, we can discuss it here. We can discuss this kind of movement based on accelerated motion, but you have always acceleration of 9.81. Okay, let's discuss it. I want to categorize these movements. The first one, it is accelerated motion along horizontal line. Therefore, this is the first group. And I proved 3 equations for accelerated motion, if you recall it. The first equation is velocity. V is at plus v0. X, sorry, x equal to half at squared plus v0t. And the next one is v squared minus v0 squared equal to 2ax. These equations are valid for the first group. Right now, I want to switch to second group, which is free fall. You know, free fall is vertical motion, unlike the first group, because first group is horizontal motion. Therefore, here you have free fall. Okay, actually, both of them have accelerations. Therefore, free fall is a kind of accelerated motion. It means these equations are valid for free fall, but you need a little modifications. I'll show it to you. For example, first equation, of course, you have the equation here for free fall. But if you remember, I told you, instead of acceleration, you have gravity. It means A equal to G here. You have always G. Therefore, instead of A, you should put G, gravity, and G is 9.81. That's constant, and it is always unique number. GT plus V0. This is the first equation for free fall. G is 9.81 meter per second square. It is always this number. But you can have different numbers if you are close to different planets. I'll talk about it later. The next one is displacement equation. You know, along horizontal line, you have X or displacement. But along vertical line, instead of X, you have H. Therefore, H stands for height because that's vertical. Therefore, you have height traveled by your falling object here. H equal to half. Again, you have gravity. You should put G, which is the acceleration of your particle. T is T square plus V0 T. And you know V0 is initial velocity. Is initial velocity. And unit is meter per second. The third equation, so you have this V square minus V0 square, 2 times acceleration, that's G, times displacement, you know, that's height. Therefore, that's 2GH. This is equation number 3. So H is height. Sorry. Unit meters. Okay, now consequently, in order to analyze the free fall, you have to use these 3 equations. Here, example. There's a falling object here. At the beginning, it has initial velocity, or it will go downward by V0. See, origin is downward because you have vertical motion. If V0 initial velocity is 4 meters per second, what is the velocity of this falling object after 2 seconds? What is V? Find V here. Okay, that's completely clear and straightforward. Use equation number 1 or V equation because you have a T and you have always G. You should memorize this number, 9.81. You have to memorize it. And you have V0. Therefore, just use the first equation here and plug it. V is GT plus V0. That's 9.81 times 2 plus 4. You know here 9.81 times 2. 18.62 plus 4. Therefore, velocity of your falling object is 23.62 meter per second. Next example. Here's a falling object and it has initial velocity of 8 meter per second. What is the required time to reach velocity of 24 meter per second? Means what is t value for this velocity? What is t? So let's apply it. V equal to gt plus v0. Therefore, v final velocity is 24. Plug in. G, it is always 9.81. You should memorize it. T is unknown plus 8. Therefore, 9.81. T equal to 16. Therefore, T is 16 over 9.81. Which is T is 1.63 seconds. Answer of the question. Thank you.